Quantum mechanics is a physical science dealing with the behavior of matter and energy on the scale of atoms and subatomic particles, waves. It also forms the basis for the contemporary understanding of how very large objects, such as stars and galaxies, and cosmological events, such as the Big Bang, can be analyzed and explained. Quantum mechanics is the foundation of several related disciplines, including nanotechnology, condensed matter physics, quantum chemistry, structural biology, particle physics, and electronics. The term quantum mechanics was first coined by Max Born in 1924. The acceptance by the general physics community of quantum mechanics is due to its accurate prediction of the physical behavior of systems, including systems where Newtonian mechanics fails. Through a century of experimentation and applied science, quantum mechanical theory has proven to be very successful and practical. In the strange world of particle physics, the two main types of elementary particles are quarks, leptons and their antiparticles, differentiated by their individual properties, including mass, charge and spin. The building blocks of matter, fundamental particles, come in many more flavors than the basic few that make up the atoms we're familiar with. Flavor is the name scientists give to different versions of the same type of particle. For instance, quarks, which make up the protons and neutrons inside atoms, come in 6 flavors: up, down, top, bottom, strange and charm. Particles called leptons, a category that includes electrons, also come in 6 flavors, each with a different mass. For example, all quarks have the same spin, half, and 3 of them, up, charm, and top, have charge 2/3, while the other 3, down, strange, and bottom, have charge of -1/3. While it is the opposite for antiquarks. Each one has a unique mass. What's even stranger is that particles are able to switch from one flavor to another. For example, down quarks can easily turn into up quarks, and charm quarks can turn into strange quarks, and so on. While some transitions are more common than others, in theory, most flavors of quark can transition into most other flavors. Protons are composed of 2 up quarks and 1 down quark, whereas neutrons are composed of 1 up quark and 2 down quarks. Quarks can't be measured, because the energy required produces an antimatter equivalent, called an antiquark, before they can be observed separately. Among other reasons, the mass of quarks is best determined by techniques such as using a supercomputer to simulate the interactions between quarks and gluons, with gluons being the particles that glue quarks together. Quarks are particles that are not only hard to see, but pretty much impossible to measure. These teensy tiny particles are the basis of subatomic particles, called hadrons. With every discovery in this field of particle physics in the past 50 years, however, more questions arise about how quarks influence the universe's growth and ultimate fate.